Hi team, welcome to Wiggins Maths. In this video we're going to be reintroducing the idea of arithmetic sequence. Now this is something you'd have done earlier on in school, maybe in Key Stage 3, certainly at GCSE. But we're going to have a slightly different take on it. So first of all, have a look at these sequences. Which of these are arithmetic? So all an arithmetic sequence means is it goes up or down by the same value each time by adding or subtracting. So as we can see, this first sequence goes up in threes. That is an arithmetic sequence. This second sequence goes up in fives. That is an arithmetic sequence. This third sequence goes up by 5, then by 6, then by 7, then by 8. So not a constant difference. That is not an arithmetic sequence. So what else will you have been asked to do beforehand? You've been asked to find the nth term of a sequence, an arithmetic or a quadratic or something like that. Now at A level we use this notation to represent the nth term, where un represents nth term, u1 will represent the first term, u3 the third term, and so on. Now at GCSE you may have just looked at this sequence and gone, well, it's going up in threes. The first term is a 2, so it's going to be 3n subtract 1. And that's absolutely right. Okay, definitely the correct nth term, but at A level we look at it in a slightly different way. So at A level what we should be doing is we should be using the first term, which we represent with the letter A, add the number of terms take away 1 multiplied by the difference between the terms. Now let's just show you that this means exactly the same thing. Okay, so again GCSE you would have said, well, it's clearly 5n at 2. And you would be absolutely right to say that. So un, using our more mathematical approach at A level, so un is equal to 7, add, the difference is 5, and then when you expand and simplify, we'll get 5n add 2. Now you might be thinking, well, what's the point of that then? Why can't we just use the easy approach? Well, if we look at this second example, it is a lot more challenging if we use the GCSE approach. So we've been told the third term is 5 and the 8th term is 20, and we've been asked to find the nth term. Okay, the only good thing is we've been told it's arithmetic. So u3 is the first term, add n subtract 1 lots of the difference. So n in this case is 3, so it's 2 lots of the difference. So we can say that a plus 2d is 5. Now the 8th term is a plus n subtract 1 lots of the difference. That's 7 lots of the difference. So therefore we can say that a plus 7d is 20. Now hopefully you can recognise we actually have a pair of simultaneous equations here. So if we were to subtract those two from one another, we'd end up with 5d equals 15. So the difference is 3. Now we can substitute our value of d into either of these. I'm going to go for this term here. So that tells us that a is in fact negative 1. So our nth term, un, is negative 1 plus 3 lots of n subtract 1. So this is negative 1 add 3n subtract 3, and then finishing off that is 3n subtract 4. Now let's just test this. So the third term, 3 lots of 3 is 9, subtract 4 is 5. 8th term, 3 lots of 8 is 24, subtract 4 is 20. Okay, and that is a lot more challenging if you to use the GCSE approach. Well, you simply wouldn't be able to do it using the GCSE approach. Okay, so Remember, by watching the video doesn't instantly mean you'll be able to do it. Practice is the key to success, and the more you practice, the better you will become. And of course, amateurs call it genius, masters call it practice.